Transfer of Energy and Information is a physical science unit incorporating ideas about characteristics of waves and how waves can be used to communicate. Let's look into the unit at a glance. This unit covers several fourth grade physical science standards about how energy can be transferred from place to place or be converted from one form to another, and about patterns that are created by wave motion. Two of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. Take a moment to pause the video and review them. In this unit, students try to figure out how waves, coding, and energy transfer are used to communicate. The anchoring phenomenon used to connect students to the science content is an image of a person speaking on a cell phone, an experience students have had or observed daily in their lives. During the unit, students will discuss this phenomenon after they have learned about how waves can cause objects to move and how energy is transferred from place to place. This phenomenon will drive students to the discussion about how waves and code can be used to communicate over long distances based on the characteristics of waves and the relationship between waves and energy. The design challenge for this unit is a culminating activity in Lesson 9. Students are tasked with designing a device to communicate over long distances. After exploring how codes are patterns that can help humans communicate with each other, they develop their own code. To design their device, students must create a circuit that uses light or sound to transmit the code they created and communicate with someone over a distance. Now that we have an idea about what students will study in this unit, take a look at the unit flowchart. This unit is divided into 3 sections and there are 9 lessons total. In Section 1, students create models of waves to observe characteristics of wave motion and consider how patterns of waves can be used to communicate. This section will take about 9 instructional days. Here is the content level big idea for Section 1 and how students will figure it out. Students use flashlights, tuning forks, and ripple tanks to explore how light and sound waves travel through different mediums. They continue to explore wave properties of amplitude and wavelength using slinkies, then apply this knowledge in observations and explorations of wave motion across water. In Section 2, students continue to explore ways light and sound energy can be used to communicate, adding observations of electrical circuits and energy transformation to their labs. This section will take about 8 instructional days. They use mini light bulbs, motors, buzzers, and energy balls to observe how energy moves in a circuit. They also use energy dice and circuits to model how electrical energy can be transformed into light, heat, and sound. In Section 3, students make connections between energy transfer, communication, and coding. This section will take about 9 instructional days. Students use books and videos to learn about patterns such as Morse code. They learn about telegraphs and cell phones as examples of technology that help humans use code to communicate over distances. In Lesson 9, students are presented with the design challenge. Using what they have learned about energy transfer, patterns of wave motion, coding, and communication, they use the engineering design process to design a device that uses patterns to communicate a message over a distance. By the end of this unit, students will understand that waves move in patterns, energy can be converted from one form to another, and humans use devices to communicate that transmit a signal or code over a distance. For more information, visit our website, myscipartners.com. mySci, inspiring the next generation of scientists.